All right, looking at graphing quadratic functions, we have 3 different forms that our equation can be written in. The first one is translation form. That's what we've done before, just using things moving to the right and to the left, up, down, stretch, reflect, compress, all those things. The next one is root form. We're going to look a little more about what your roots are here in just a second. And then the last one is standard form. I would say standard form is probably the most annoying one to have to work with, but they're all just fine and you will be okay. So looking at translation form or vertex form, this is also sometimes called vertex form, because they give you the vertex of the equation of the graph in the equation, okay? So notice, just like this is going to move your graph to the right 5, this is going to move your graph down 8, that makes your vertex 5, negative 8. From there, I can go ahead and go right 5, 2, 3, 4, 5, down 8, put my dot. After that, don't forget the 2 in front means it's stretched. So remember that you're going to go up twice as much. I'm going to go ahead and rewrite down your table right here that's normally, remember it's negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. Okay? Remember when you stretch that, it's going to go up twice as much. So from this point, usually I go 1, 1. Now I'm going to go over 1 and up 2 on both sides. Then usually it's 2, 4. Remember now it's going to be 2, 8. And that's enough to draw my graph. Okay. So same thing on question number 2. This graph just moves to the left 5. So if it's moving left 5, then you can go ahead and find your vertex. Your vertex is going to be negative 5. And then if it doesn't move up and down at all, then negative 5, 0. Okay? Negative 5, 0. So again, I know this moves left 5. 1, 2, 3, 4, 5. Put a dot. From there, remember the negative 1 in front is a reflection. So normally we would go over 1 and up 1. Since it's reflected, we're going to go over 1 and down 1, over 2 and down 4. And then remember, if we wanted to do one more set of points, it would be 3, 9, because 3 squared is 9. And there's my graph. Okay. Last one, again, same thing. Right 1, down 4, makes my vertex 1, negative 4. So 1, negative 4. From there, it's been stretched by 3. So instead of going over 1 and up 1, I'm going to go over 1 and up 3 on both sides. Instead of going over 2 and up 4, I would go over 2 and up 12. So this would be 4 and 8 equals 12. You see how I skipped that? It's pretty smooth, right? Great. Okay, so that, like I said, is kind of what we've already done before. When they give you the equation in root form, okay, notice that this is x minus r and x minus r2. Okay, those are your 2 roots, root 1 and root 2. Your roots are the same as your x-intercepts. So from your equation, you already know your 2 x-intercepts. So knowing that x minus 3 is a root, then I know that my x-intercept, or x minus 3 is a factor, then I know that my x-intercept is going to be at positive 3, 0, because notice there's a minus in the equation. Same thing for my second root, it's going to be at a negative 1, 0. Okay, 3, 0, and negative 1, 0. So that's what I'm going to do. Here's 1, 2, 3, 0. Here's negative 1, 0. Okay. From there, this is where it gets a little bit tricky. Okay? I know that the center of my graph is going to be in the middle of these 2 points. Okay, so that's what, looking for your vertex. I know the vertex is going to be exactly in the middle of these 2 points. So in the middle of a negative 1 and a 3 is a positive 1. That tells me my vertex is going to be at 1. If I want to find the y value of my vertex, the best thing to do is to just plug 1 into your equation. So I'm going to come over here and do that. 2 times 1 minus 3 times 1 plus 1. Well, that's 2, that's negative 2, that's 2, 2 times 2 times 2, that's a negative 8. The y value of my vertex is at a negative 8. So 1, negative 8. From there, if I wanted to find my next points, again, I know it's stretched because of the 2 in front, so it would be over 1, up 2. Remember, the next point would be over 2, up 4, which up 8. Usually it's 4. This time it'd be 8, which puts us right back on the dots we've already drawn. Okay. Same thing on our next question. The root here, x minus 2 and x minus 2. That means 2, 0 and 2, 0. Okay. This is what's called a double root. Double root. Okay. Double root. Both of them are at 2. Okay. What is going to be halfway in between 2, 0 and 2, 0? Well, how about 2, 0, right? 2, 2, halfway in between 2 and 2 is 2. Your equation, the rest of your graph from there, all you need to know is that a is negative 1. So instead of going over 1 and up 1, you're going to go over 1 and down 1 on both sides. Then usually it's 2, 4. And if you wanted to do 3, 9, you totally could. But you don't have to, I guess. Next one is kind of tricky. This one is also in root form, but it's not quite as obvious. Looking at this term, that's pretty obvious that that's going to be negative 2, 0. The one that's maybe not as obvious to you as this one, that doesn't have minus anything, so that tells you that one of your roots is going to be 0, 0. Okay? The other thing you can do, remember the roots are the same as your solutions. So you could also always find your solutions here, which is also kind of why you just go ahead and change the sign. So here's 0, 0. Here's negative 2, 0. What is halfway in between there? Negative 1. Okay? Again, if I want to know where my vertex is, I plug negative 1 into my equation. So 3 times negative 1 and negative 1 plus 2. That is negative 3 times 1 is negative 3. So 1, negative 1, 2, 3. And that makes sense because this graph has been stretched by 3. So if I wanted to do my next points, it would be over 2, up. Usually it's 4. This time it would be 12. So again, I can kind of cheat a little bit here because I know how many boxes are on this graph. It's 10, by the way. Okay. Cool. All right, the last one is the one everyone hates. Sorry. Okay. To find your vertex from this equation, okay, you are going to use this little formula right here, negative b over 2a. That gives you the x value of the vertex. Okay. Notice from this, a is what's in front of the x squared, b is what's in front of the x, and c is what the term that's by itself. Notice this one doesn't use c, but it does point out the fact that the point 0c is going to be your y-intercept. Okay, so if I use this little formula here, this is going to be a and b. So if I do a negative negative 2, all divided by 2 times a negative 1, that's 2 over negative 2, which equals a negative 1. So the vertex is going to be at negative 1. Okay. To find the y value of your vertex, this says f of that. All that means is I'm going to take what x is and I'm going to plug it into my equation to figure out the y value of the vertex. Okay. You got to watch out for these negative signs here. Remember that negative 1 squared is just positive 1. 1 times negative 1 is a negative 1. Negative 2 times negative 1 is a positive 2, plus 8, 10, minus 1, how about 9? That tells me that negative 1, 9 is my vertex. And from there, I can just count my normal points, except that it's been reflected. So it's still going to be 1, 1, 2, 4, and 3, 9, if you wanted to keep going. Okay. Remember, a nice way to check this is that the y-intercept is at 0, c. So notice c in this case is 8. That tells me my y-intercept should have been at 0, 8, which, good news, it is. That tells me I graphed it correctly. Okay. One more question like this. Okay. Again, negative b over 2a. So negative 8 over 2 times 2. That's going to be negative 8 over 4 or negative 2. So negative 2 is the x value of your vertex. How do you find the y? Plug it in, just like on the root formula. So 2 times negative 2 squared plus 8 times negative 2 plus 6. Okay? Negative 2 squared is 4. 4 times 2 is 8. And 8 times negative 2 is a minus 16 plus 6. Gross. So, negative 16, well, 8 minus 16 is a negative 8. Negative 8 plus 6 is a negative 2. So negative 2 is your vertex. Negative 2, negative 2. From there, usually it'd be 1, 1. This one's been stretched. So 1, 2. And usually it would be 2, 4. Now it's 2, 8. And there's my graph. Again, notice the y-intercept should have been at 0, 6, and it is.